Okay, we have two types of inequalities we're going to look at today. Absolute value less than an expression. Now, I didn't want to say less than a number because it doesn't always have to be a number on the other side of the equals. Okay, so absolute value is typically the quantity that I am isolating. That doesn't change. There's a lot of similarities to what we've been doing. Okay, so we're going to do less than an expression. Could be a number, could be 3x plus 5. Okay, and so I'm going to translate this. Distance, absolute value, less than a number. And we're going to do a number line. Okay. At expression, number, it's easier if we say number as we're thinking about this. Okay. Let's just, for purposes of being able to put this on a number line, I would like distances that are less than 3. I suppose distances from 0 that are less than 3. Okay, where can I put my points? 2. Just yell out numbers. Distances that are less than 3. Where on the number line can they go? Just, -1. Just keep going. Tell me any numbers you want. 1/2, yes. -2. -2.5. -2.7. +2.7. Okay, so what I'm doing is I'm plotting distances on the number line that are less than 3. Okay? Oh. Okay. I just plotted numbers on the number line whose distances are less than 3. Now, I don't want to get too carried away with the numbers, okay? So when I do distance less than some expression, I have an endpoint, a center, and an endpoint. We had centers when we were talking about absolute value equations. Okay, we still have the center. But notice this time that I shaded the number line instead of having 2 dots on the number line. Okay? Will always shade between endpoints. It's kind of a big deal. This is telling you how to set up your inequalities. Distances less than a number will always shade between the endpoints. Now this can shift around and the numbers can change, but there will always be 2 endpoints. And when you are doing less than, they will always shade between the endpoints. Endpoint less than the distance less than the endpoint. That's a between inequality. That's a 3-part inequality, maybe a compound inequality. Okay, so we're going to look at how do I do that? How do I do an example? What does it look like when I take this and I put numbers with it? So we're going to absolute value 2x plus 6 minus 1 less than 13. Okay, well I see absolute value, and so I'm still going to isolate the absolute value. Still have to do that. Okay. I still have to check my work. Can distance be less than 14? Yes. Okay, continue. Right? You got to look at your work before you just mindlessly try to solve it. This is a good equation to solve. Okay? Split it just like we do equations. Okay? So I'm going to have a left and a right side. The left of the center, or the negative direction. I'm going to have the right of the center, or the positive direction. Okay? Now I'm looking at my graph here. If I look at the part that is to the left of the center, it's shaded like this. Anyone remember from Algebra 1 what inequality sign means shade to the right? Greater than. Greater than means shade to the right. Notice that you have to go to the right of this endpoint. Okay? So when I rewrite my left side, notice I'm on the left side here. We're going to drop the absolute values. And I'm going to say, this is for the left endpoint, I need to shade to the right of the negative direction. This is not a how-to list. This is understanding why you're changing that sign to greater than and why you're changing that sign to a negative. This is where I started. I need distances that are less than 14. So I need to shade between the two endpoints. That's the only way to get distances less than a number. On the left side, I need these to go to the right of the negative direction. The greater than means to the right of the negative direction. Okay, the positive side. I need the distances to go to the left of the positive direction. Look at my setup. There's my graph. These are the two inequalities I need. I need the left side to be greater. I need this side to be less than. Notice that the positive side is almost exactly the same. Okay? So we call this switch and negate. I switched the inequality sign and I made the number negative. But you need to understand why you're doing that, not just switch and negate. Okay? Switch and negate and copy. The other side is just copying what you see. But you should understand why this one says greater than, why this one says less than. It's because of the direction that the arrows need to go. Solve, right? Solve the two inequalities. X greater than negative 20, X greater than negative 10. Okay, put it on a number line. Okay, I only need you to label the necessary points. I don't need tick marks. My endpoints are negative 10 and 4. X greater than negative 10. Now I'm going to assume you remember what that means to shade. You do, yes. But we divided by positive 2, which is why it stayed. Okay, so this means open circle, shade to the right. But not too far to the right, because I don't want my distances to be too big. basically we're shading towards the center, right? Distance is less than. X less than 4. I don't really need arrows. You can just shade between those two endpoints. Can you write it in interval notation? Can you write it in set notation? Okay. Don't just copy the inequalities. I need this short and to the point. X's are between -10 and 4. If you can write it as a compound inequality instead of two of them, then you should. Notice that my solution is a continuous solution. Means you should write it that way. Okay. Switch and negate, copy, solve. Put it all together. This is the answer in whichever format I ask you for. B. Okay, I'm just going to slip just so that I can write bigger. You guys probably have plenty of room. Okay, absolute value greater than, okay, than an expression. Okay, so the absolute value, it still has to be isolated, but this time we're looking at distances that are bigger than a number. Distance greater than a number. And we'll just think 3 as we try to put this on a number line to see what kind of picture distances more than a number represent. Okay, so I'm pretty certain that if I was equal to 3, I would be there. But I need distances that are greater than 3. Just yell any numbers that I should put a dot on the number line. 4, yes. Yep. Okay. Everything over there. Got it. What else? -4. -3.5. Keep coming. What other negative numbers should get shaded? -5, 3.1. Yes. Okay, there it is. Okay. Everything to the left of -3. Okay, notice my answer is not continuous. And that my arrows are going opposite directions, away from each other, away from the center. That represents distances that are greater than. So I have my center. Okay, I have X less than the end point, less than the left end point. I also have X greater than the right end point. Not continuous answer. Okay, so let's set up what the inequality would look like. Okay, let's do a 1/2 absolute value 2x minus 3 plus 1, and we'll do greater than or equal to 3. Okay. Isolate. Right? Doesn't matter. Equation, inequality, isolate. Okay. So we get 2x minus 3. So I'm going to minus 1. Then I'm going to times by 2 over 1. 2. Greater than or equal to 4. Okay. I got it. I isolated it. I still have the negative direction and the positive direction. Okay, negative, or to the left of the center. What's happening to the left of the center? I need my arrow to go to the left. Okay, so arrow has to go to the left. So we're going to say 2x minus 3. The arrow has to go to the left. Look at my inequality sign. On the left of the center, the arrow has to go to the left and the negative direction. So if I look at where I started and what is different, I switched the inequality sign, switch, and negate. It's the same step as the other one. It just looks, right? Just different direction. It's okay. The positive, or to the right of the center. To the right of the center, I need the arrow to go to the right of the positive direction. Being able to set this question up implies you remember the general picture that you're aiming for. Distances greater than 4 means I'm trying to get numbers that are away from the center, right? Bigger than 4. So the left has to go to the left, and the right has to go to the right. The left goes to the left, and the right goes to the right. And solve, right? Solve the two inequalities. Okay, notice that my answers are actually going opposite directions. That's good. They should be going opposite directions every time. Arrows are either pointing at each other or they're pointing away, but they're going opposite directions. All right? I did multiply by 2, but yeah? Okay. All right, let's put it on a number line. In order, numerical order. Okay, closed dot this way. Closed dot this way. Are my distances greater than 4? Yeah, they are. They're going away. They're more than 4. I could find the center. That's not really the important part. You're looking for your distances to be more than 4. Yes, I should put a little blue cloud. Like, yes, I should continue solving that. Distances are more than 4. Okay. Can you do interval notation? Can you? Oh, it's not a continuous answer. It's not continuous. You have one interval for each piece. Could you do set notation? Okay, yeah, I can do set notation. Is this a continuous answer? No. Means you're going to have one inequality for each piece because it's not continuous. X less than or equal, or X more than or equal. Notice that the combined answer, the between, was a between inequality, and this one is not. There's a little story that goes with this. What do you row a boat with? Oars. Oars. You row a boat with oars? Put a boat between your two oars. Okay, greater than. It sounds like greater. Your greater thans will have a boat between your two oars. I know, it's pretty lame. One last thing. Special solutions. The ones you don't solve, right? The no solutions. Right? We're always checking that portion of an absolute value statement. Can distance, right? I'm translating, and this is what I say to myself. Distance less than 0. Yes or no? Can distance be less than 0? Guys, do not solve past something that does not have a solution. You will get confused by what it looks like. So you have to evaluate it. Before you split it, you always got to read that statement to make sure. Okay? What if I say this? Right? You got to read it before you split it. Okay? This is what I'm reading to myself. Distance more than or equal to -3.
What?
Will distance be greater than or equal to -3? Greater than or equal to. It's an or statement. Greater. Can you say yes to either? Greater than -3? Yes. Or equal? But I said greater than. If you evaluate for any number, are you going to get a true statement? Is a positive number, okay? I'm going to read it another way because I'm like, oh, that equal, it's throwing me off. Is a positive outcome greater than or equal to -3? Is that always true? Always true. All real numbers, because the statement is always true. Now there's a bunch of combinations, okay? So you have to read the statement and figure out if it's possible for it to be true. If you're ever concerned, you can always plug in and check your answers. You can check your endpoints. You can check the places that you've shaded on the graph. They should be true if you shaded them. All right, that's where we'll stop. I think what we'll do is just start your homework. Just start your homework, guys. We'll do the Desmos thing. We'll add it to some of our practice next class. Okay? So just start your homework in worksheet 8. You're going to practice a lot of your PEMDAS in your worksheet. Make sure you're setting things up correctly. So you've got 10 minutes now, guys, so use your time wisely. Yeah, sure. Oh, that's your quiz. Oh, thank you. Sorry, I missed that. All right, Sean, do you want to do your other one? Yeah. There you go. Yep. Oh, I didn't get it. Oh, thank you, Riley. Okay, I'm coming around to check the rest of your homeworks. I think I left off somewhere around here.
Excuse me, Mrs. Breezy.
Hi, what's up?
So for like this one, like
okay.
specifically right
So
before.
here's what I'm gonna do. I will change one. Right, we'll kind of like average the two because it's the same mistake
Do that
both
one.
times. Yeah, that's fine because you got a chance on this one. Oh,
Well, the
that's
thing is,
fair.
like, literally,
I got you.
right before you told me about it, and I knew it, so like I wrote the Y small. I just did that like so
To
I
help
remind
yourself?
myself, like,
Okay.
make sure I knew that.
Let
it
me
was the
find
Y
my
bar and
clipboard
then
before.
I could write that.
Idris, get your homework out.
Oh, I don't have my.
Okay, you know what you can do? You can just borrow mine and put them on paper for now. There you go. Just do them on the back of your notes. Okay, 2, 1, 2, 4. Deal.
Technically, because it's encapsulating multiple lines, and
Yeah.
it's Y equals, it's like this one big piece equals these different lines. Using Y equals is still.
I should only have it in one place. It should only be in one place still. Yes, hi.
So, if it's like
Yeah.
less than or equal to, then
It would just be including hard bracket the endpoints.
okay. But then if it's like for this,
So for this one ends up being x absolute value x minus 4 greater than negative 11.
so you just do it with open.
Yes, which actually greater than a negative number.
Oh well, yeah.
Yeah.
But like,
But let's just say you would end up with open circle endpoints. So
Yeah.
for this one, you would end up having, okay, so absolute value less than 4. So I'm going to get open circle together graph, right? The in between graph.
but
yes.
not the distance couldn't be like equal to negative.
Okay, so
why
it's
is it
it's greater than or equal to, which means one or the other is true. That's what or means. One or the other. If I say less than or equal, it's or. It's one or the other. It's either going to be less than or it's going to be equal to. But either way, because it's always going to work. Think of so. Then that's why I wrote my second statement. I was like, okay, that weirds me out to say equal to a negative because I'm like, no, I don't think so. Whatever you plug in for x is going to be a number. Okay, negative 4. It's going to be 0. Is 0 greater than negative 4? Yeah. Well, if you weren't looking at the equal part, you were looking at the greater part, right? And like one or the other of those statements is true. It's like two sentences. Is this greater than negative 3?
All sizes,
Yes,
all races, all
Is it equal to negative 3? No, but it's one or the other that's true.
What if it's like both? Oh wait. Yeah.
Right? Yeah? Okay. All right. Yeah, I just gotta pass that. Okay, start your homework. Have your packet out.
Look, it's negative, if it's positive, it's going to be
Yeah, it's always switching the gate for the other side. Which you could reason it out. The left side has to go less than if it's greater. Or the left side has to be more than if it's or. The answer is either go towards the center or outside the center. You just work it out.
Oh, no, we're presenting tomorrow.
Yes. Is distance more than -11? So you have to, this can be, you can word these things any particular way. You just gotta read it. Yes. I have it missing, but 6 and 7. On a number, so you would subtract the 5. It gets distance less than what it is. Okay, sure, seems reasonable. Means that now split itself. So if your distance is less than, that means I need to go towards the center. Okay? That means the left side has to go with the greater than negative distance.
Wait, that's always the distance.
You're not going to solve with that number, right? You're not going to solve with that number. So how do you know when it's... Okay, distance less than 3. Goes towards the center. Oh, that's the... Yeah, okay. So I got this. So first, like, okay, distance is going to be... I got to go towards the center. That's easy. Okay, now you guys... It's going to go away from the center. So you look at that. Yes, okay, so I got this. To the left of the center, I got to make it go... How do I make my shape? Honestly, 3x minus 4 greater than negative 22, right? Because I'm already on the left side, so I'm comparing to the negative direction. You got it? See, but like, now I got it. So actually, here, so for me, it's a lot more than like, I'll go up to 2 miles.
This is less than the negative becomes greater.
It's always switching the gate. It's just either going to go like this or like this. If you plug in something that you have shown, it should be a true statement. So if I were matching multiple choice, I might like this check.
And would these be greater?
Yes, my dad is. Yes, he is. You decided to be extra.
I want a cowboy hat. I just go to college.
Yeah. He's something like, and he said that like,
Right, are you Tokyo
he's
Drift?
gonna like yell at me. I mean like, not yell at me. He'll always steer home.
You're Tokyo Drift?
Yeah,
Ryan Drifts all the time.
This one.
You look up, so look at all these songs. Wait, what do you say? Justin Bieber.
I'm ready.
It's not Spanish. You like Justin Bieber?
We got it.
You said you like just to get a one. Yeah.
Honestly, it's better than mine.
Why not Ariel Grande? What do you mean, baby? Right. You like the baby? But.
It was left for and should have faded above. This one, no equals, just plain equals. And you should have solved your. Alright, but the retake of this is Wednesday. Okay. Hi, yes. Yeah, grab a seat.
I don't know why I thought I was leaving. I didn't realize that I took that.
Well, if you want like 2 minutes to go do whatever you need to and then come back, I'm not going.
Oh, okay.
Yeah, I'll be here till like 3:40 today. Yeah. See you later, guys. See ya.
Thank you.
See ya, guys.